So we started with the definition of what an acid and a base is in the Bronsted-Lowry formalism, but since then we've pretty much exclusively treated strong and weak acid equilibria in water. So let's talk a little bit about weak base equilibria, which turns out to be all the identical mechanics, but we're dealing with a slightly different reaction where the proton is accepted rather than donated. So let's look at a really simple example, which is ammonia, NH3 in water. So ammonia, under the Bronsted-Lowry definition, is a base because it can accept a proton to make the conjugate acid over here, NH4+. In doing so, it must react with an acid. In this case, water is acting like the acid instead of the base, and that forms hydroxide as the result. And so I've labeled the base and the acid on both sides, just like we did with weak acids, and I've also connected the conjugate pairs via these arrows. So every equilibrium system has an equilibrium expression and constant, so this is no different, but instead of using Ka that we use for the dissociation of an acid, now we are associating a base by adding on a proton, and so we're going to call this Kb, and we'll write up an equilibrium expression for this system. So pause it and see if you can do that, knowing that water, again, is the pure substance in this system. So we should have something that looks like this, and now we have the Kb, which is the base association constant because it's associating with that proton to form, in this case, the conjugate acid. So to solve a question like this, if we were given some initial amount or concentration of NH3 and we could find the Kb in a table, then everything else in terms of the treatment of these systems to determine what the concentrations are at equilibrium, the pH, etc., it's all identical, exactly the same. It's just now that we are writing up the reaction slightly differently because it's no longer acid dissociation, it's base association, and for that it has a Kb and not a Ka. So let's think about here for a second what the relationship between Ka and Kb are.